Hey, welcome back. We're going to go through page 10 now. Okay, number 10. A cube of ice has side length of 5 centimeters. The mass of the cube of ice is 114.5 grams. Find the density of ice. Okay, so they've not given us the volume here. They've given us the mass, and they want us to find the density, but they haven't given us the volume. And of course, that is the final thing needed in our formula triangle to find density, because density is mass divided by volume. But they have told us it's a cube with side lengths of 5 centimeters, so it's not that hard to figure out what the volume is. Oops. Okay, so the volume of a cube is length times width times height, and then they're all 5. 5 times 5 times 5, or 5 cubed, is 125 cubic centimeters. Okay, so the density is 114.5 divided by 125. That's 0.916. Okay, shown is a solid cylinder made from carbon. The density of carbon is this. Find the mass of the cylinder. So again, we've got to find the volume first. Okay, so this is a cylinder. To find the volume of a cylinder, we need to do the cross-sectional area, which is a circle. So pi r squared times by the height. So there's the volume for the cylinder. So we need to do the radius would not be 8, it would be 4. 8 is the diameter. So we're doing pi times 4 squared, or pi times 16, and then timesing that by 15. I'm just going to do all of that in one step. And I'm going to leave this in terms of pi for now. Okay, so that gives me 240 pi. And the reason I'm leaving it in terms of pi is because it's not my final answer. I don't want to do any rounding at this stage. So mass is density times volume. I've got my density there. This is my volume, and it is in cubic centimeters because both of these are in centimeters. Don't forget the pi, it's not a unit, it's actually part of the answer. And that gives us 468 pi, but that as a decimal is 1470.3 grams, grams, yeah. Okay. Right, number 12. Material A has a density of 4.5 grams per cubic centimetre. Material B has a density of 14 grams per cubic centimetre. So B is denser. 5 kilograms of material A and 200 grams of material B form material C. Work out the density. So imagine if you could melt these down, mix them together and form another material. That's what we've done here. Now you can't just take the average, the mean average of these two things, the number in the middle, and say that that's the density of material C. It depends how much of each one we have. So here's how you do a question like this. We figure out anything we can for what we've got so far. So at the moment, for material A, I have its density and I have its mass. Okay, so its density is 4.5 and its mass is 5 kilograms. So I'm going to put that in grams because this is in grams per cubic centimetre. So its mass is 5,000 grams. Okay, but I don't have its volume. I'm going to figure that out in a minute. Material B, I have its density and I have its mass. Again, I don't have its volume. And material C, I need to find its density. Now, you might think I don't have its mass, but if we combine 5,000 grams of material A with 200 grams of material B, we can just add those together to give me how many grams material C will weigh. I can't just suddenly gain extra weight out of nothing, nor lose weight. Arguable, that last one, depending on what would happen during a process of combining two materials. But for the purposes of this, we're going to have, this is just going to be the sum of the two masses. And also the volume here will be the sum of these two volumes. Again, you can't combine two things and then just lose some space or gain some space. So I'm going to work out the two volumes of A and B, add them together, that will give me the volume for C, and then I can use that to work out this missing one here. Okay, so volume is mass divided by density, so 5,000 divided by 4.5 gives me 1,111.1 recurring. The volume for this is 200 divided by 14, so 14.3 if I round that. Okay, so if I just round these, let's get rid of that recurring dot. So the overall volume, if I add those together, is 1125.4. And to work out a density, I would do mass divided by volume. And that gives me 4.62. Or 4.6. I'll just give it as. Okay, so it's volume, its density is closer to that of the density of material A because we had much more of material A in this material. Okay, 180 grams of copper is mixed with 105 grams of zinc to make an alloy. So a very similar question to the previous one. Work out the volume of copper used in the alloy. So I've got the mass and I've got the density of copper. So density is mass over volume. I want to do mass divided by density. So 180 divided by 9 is 20. So I've got 20 cubic centimeters of copper. What is the density of the alloy? So I want to know the volume of zinc I've got as well. So I'm going to do the same thing here. 105 divided by 7 is 15. So 15 cubic centimeters of zinc. So altogether I have 35 cubic centimeters of the alloy. And it would have a combined mass of 285 grams. So from that I can work out its density. So 8.1 to 1 decimal place. Again, just looking at the densities we've got up here, it's between the two, which you would expect. Right, number 14, find the pressure exerted by a force of 180 newtons on an area of 50 square centimetres. So this is our third and final compound unit we need to know for GCSE maths. And that is pressure is equal to force applied divided by the area it is applied to. Okay, so you could remember this one by Professional Football Association or anything like that. Okay, so pressure, we're going to do 180, that's the force, newtons, divided by the area, so 50. That's 3.6 newtons per square metre. Another number 14. Whoops. A cylinder is placed on a table. The cylinder has weight 400 newtons and a diameter of 10 centimetres. Work out the pressure on the table. So the surface which is transferring this pressure, if it's a cylinder, will be a circle. Okay, so it's all to do with the surface that's transferring all the force. So we need to work out the area of the circle. So hopefully you remember that area is pi r squared. And if the diameter is 10, then the radius must be 5. And leaving this in terms of pi, that will give us 25 pi. Okay, so pressure is force divided by area, so 400 divided by 25 pi will give us our answer. .1. Final question, 2 cubes are placed on a table. One cube has a side length of 4 centimeters and the other has a side length of 10. The weight of the smaller cube is 50 newtons and the weight of the large cube is 250 newtons. Which cube exerts a greater pressure on the table? So just to give you a sketch of what's going on here. We've got a smaller cube, side lengths of 4, and a larger cube, with side lengths of 10, but the weight of the smaller cube is less than the weight of the larger cube. So which one is going to exert more pressure? Well, let's have a look. So the area of the base of this cube is 4 squared, so 16. So our force is 50, divide that by 16, this will give us the pressure. So that's 3.125 newtons per square meter. And this one, the area of the base of this cube would be 100, 10 times 10. Oops. So I want to do 250 divided by 100. And that of course would be 2.5 newtons per square meter. So despite the fact that this had less weight, it is exerting greater pressure. Okay, thanks for watching.